Awesome. Well, thank you everybody for joining us this evening. Super excited to be here today, and this is our Cambridge Data Meetup for the month of March. I think we do this monthly, or at least try to be as monthly as possible, and it is an event that Google sponsors with Google's customers and also one of the partners. So the partner for this month is SADA, and by way of introduction, my name is San Tongprasert. I lead our customer engineering team at SADA for the New England and New York region. I'm super excited to be here today, and hopefully it's a lot of fun. And for those that don't know SADA, SADA is a Google Cloud partner. We are the largest reseller and GCP-only professional services company. We have been Google Cloud partner, I think, for the past 10 or so years now, and we've been #1 partner for the past 5 years. But anyway, enough about SADA, enough about myself. We're here today to learn about Dataproc. Really, today is all about y'all learning what Dataproc can do, deep diving into the technology, seeing how companies like TAMR uses Dataproc in their product development to deliver business and technical outcome. So yeah, if you have any questions, please do save them toward the end. We have fireside chat. And this is supposed to be fun and engaging, so feel free to walk around and network with people and peers here during the breaks. And let's kick in. The agenda, just high level, is going to be deep dive into Dataproc. We'll go into how TAMR uses Dataproc, and at the end, fireside chat. And without further ado, I'm bringing up our first presenter, Jay.
Thank you. All right. Hi, everyone. My name is Jay O'Leary. Oh, I'm going to click this. And we're going to start with a deep dive of Cloud Dataproc and learn about its heritage from Hadoop. And then after I go, TAMR will talk about how they use Cloud Dataproc in production. So we're going to start off with a little bit of history about Hadoop and Dataproc, go into what is Cloud Dataproc, talk about why and how you might use it, talk a little bit about the architecture, and then at the end, talk about when to use which version of Dataproc. There's a standalone version on GCE, there's a version on GKE, and then there's also a Spark serverless version. So a little bit about myself. My name is Jay O'Leary. I'm a data and analytics customer engineer working in the Northeast region. I've been at Google about 3 years, and in the data analytics space for a couple decades. Before Google, I was at Cloudera as a partner engineer, helping ISVs integrate Hadoop into their software stack. Really happy to be out in the public and presenting on Google Cloud Dataproc today, especially it's nice to be in person after having been kind of on hiatus for 3 years with COVID. Some coworkers have told me that, if I'm a little nervous, it might be good to tell a joke to break the ice before we start. Unfortunately, all my dad jokes have been used. So I figured I would ask Bard, our generative AI Google tool, to come up with a joke for me. So I asked him, give me a dad joke involving technology. So it came back with, why was the mobile phone wearing glasses? Anyone? It lost all its contacts. So, needless to say, I think the writers at Comedy Central are okay for a while. So, when we talk about Google and data, we say internally that big data is in our DNA. And we have 9 products that have over 1 billion users each. And so when we talk about Google scale, those are the types of problems that some of our internal product teams have to deal with. And on the right-hand side, kind of talk about all the issues that come up with dealing with those types of products, such as performance at scale and real-time insights. But today, we want to focus a little bit on interoperability and openness. So Google, over the last 20 years, has been solving big data problems. And if you look on the left-hand side of this red graph, you see GFS and MapReduce, two of the seminal papers that were written by Google and then taken by the developers of Hadoop to make that into a product. So I'm just curious, for folks in the audience today, how many are familiar with or have used Hadoop? Oh, a good percentage, almost half. How many have used Dataproc? Okay, a little bit less, about a quarter. So just a little bit of history for Hadoop. As I mentioned, 2004, Google released two papers on MapReduce and GFS. In 2006, some developers inside Yahoo developed Apache and had clusters set up in the thousands of nodes. And there was one developer at Yahoo that really was preeminent in creating Hadoop, and he was the one who named Hadoop. And if anyone can tell me his name, you get this beautiful Google Cloud hat. Anyone know?
Doug Cutting?
Doug Cutting.
That's an easy one.
Yeah. So Doug Cutting created Hadoop, and then later on went on to co-found Cloudera in 2008. In 2009, Apache Spark was created. Apache Spark now is part of Dataproc, but is also a big part of Databricks, which was founded in 2013 on the number 2 in the orange row below. In 2011, Hortonworks was formed, which is interesting because Hortonworks and Cloudera were both comprised of Yahoo employees, and they kind of battled each other until about 2019 when they merged. But unfortunately, they had spent so much time competing with each other that they were late to the cloud. So you can see in 2009, AWS released Elastic MapReduce. In 2015, Google released Dataproc. So by the time, close the microphone. Which one? Oh, get closer. In 2009, sorry, I lost my place there. In 2015, Google released Dataproc. So the Hadoop ecosystem really developed because of a need to analyze very large data sets. Before the early 2000s, the idea was to bring the data to the processors. With Hadoop, the advent of distributed processing was announced, and so we would store the data with the processors. On-premises Hadoop clusters became very popular, especially in the financial services industry and others. There were a lot of problems. The clusters were not elastic. It was difficult to scale. There were capacity limits, and there was no separation between compute and storage. So if you wanted to grow your cluster, you basically had to expand the size of each node or add more servers. With Cloud Dataproc, that's simplified by adding Hadoop workloads on GCP. So it has, Dataproc has built-in support for Hadoop. It manages the hardware and software configuration for you. It's got simplified version management and also flexible jobs configuration. So what is Cloud Dataproc? It's a fully managed, scalable, and available service for open data analytics with choice of compute and support for ephemeral and long-running workloads. So one of the main processing engines on Dataproc is Spark. There are others such as Hive, Tez, MapReduce, Presto, and others. And you can run those on Cloud Dataproc with compute options running on Google Compute Engine, Kubernetes Engine, or serverless. So some of the features that you get with Cloud Dataproc, The platform is fully managed. You get rapid cluster creation in under 90 seconds. You get all your familiar open source tools, customizable machine types. You get ephemeral clusters on demand, and Cloud Dataproc is tightly integrated with other Google Cloud Platform services. Some of the use cases, data engineering at scale for massively scalable data engineering use cases using Apache Spark or Flink. Machine learning at scale, near real-time stream processing. You can use it as a serving layer for querying Presto, Drill, Impala, Hive, or other engines. If you have a requirement to run Apache HBase in a managed infrastructure, you could use Dataproc for that. You could use Dataproc to run Apache Kafka, or you could lift and shift your on-premise cluster to Dataproc in the cloud. A couple of examples of very large customers. Twitter, they have over 500,000 cores with accessing 300 petabytes of storage, 12,500 nodes, processing over 1 trillion messages per day. Pandora, another customer, similar size, 2,700 nodes, 7 petabytes, and 120,000 tables. So some more about some of the salient features of Dataproc. It's fully managed, secure. It disaggregates compute and storage. There's a choice of 30+ open source services. You can customize the machine types and images. You get rapid cluster creation with auto scaling and zonal placement. You can use an internal or external metastore. So the external metastore is useful if you want to shut down a cluster and then later on start another cluster with the same metadata. You can use it as a notebook to serve notebooks. You can store your data to GCS for persistence. You can create ephemeral clusters on demand. You can also have long-running clusters for jobs that run more often. There's a jobs API for instantiating jobs. And it's tightly integrated with other Google Cloud Platform services. So Dataproc has several form factors. You can run as a single node, say in a dev or QA environment. The standard configuration is 1 master node, 3 workers for maybe a developer cluster, and then for a highly available Dataproc cluster, you would have 3 masters and many workers. We also have a couple different cluster tenancy options. You can use a personal cluster where it's using Kerberos to access the data on the server as a single user, or you can use service accounts in a multi-tenancy mode. A little bit of Cloud Dataproc under the hood. As you can see, Cloud Dataproc is a managed service, but there's a lot happening. So there's networking, storage, compute, the metastore, as we mentioned, a user-managed service account, and if you need to have custom images, that's also an option. Let's talk a little bit about the architecture. There's basically 3 different types of nodes. We have a master node, a set of primary workers that are responsible for managing HDFS. And then we have secondary worker nodes that are usually preemptible and part of a managed instance group so that those can be shut down as if the amount of work that's being done on the cluster is lessened. this diagram just shows a little bit more about that particular architecture with Cloud Dataproc on the outside and some of the engines that we can run inside with, being Apache Spark, Hadoop, MapReduce, Apache Hive, Presto, and others. So to recap, Cloud Dataproc managed Yarn cluster for Hadoop, Spark, Pig, Hive. You can deploy a cluster in 90 seconds and pay per second. You can add or remove workers with 0 downtime. And you can customize Apache Hadoop image with initialization actions. When would you choose which flavor of Hadoop? So we mentioned earlier that Dataproc runs on GCE, it runs on GKE, and it runs in Spark serverless. For GCE, if you just want to manage cluster, Apache Spark 3.1, 90-second startup time, long-lived or ephemeral cluster, then it would be an ideal fit. If you just wanted a Dataproc cluster, you don't want any infrastructure overhead at all. You don't want to have to pick the network. You don't want to have to pick the image type. You don't want to have to pick the compute type. Then Spark serverless is a good option. Dataproc on GKE is more effective for batch jobs and streaming jobs where you have a shared persistent development environment. So that is all I had on Dataproc, and I'll hand it off to the TAMR folks.
So this is an introduction to Dataproc on the back end. I'm going to talk about Dataproc as a user. So let me get to know you a little bit better. First thing, show of hands, who has used Spark? Spark users? All right, roughly half of you. Second question, whose inbox has been bombarded lately with messages and messaging about data products? Very few, all right. Awesome. So I'm going to talk about TAMR and data mastering on Dataproc. My name is Nick Bates-House. I'm chief architect at TAMR. I've been with TAMR about 10 years now. And to avoid confusion, I'm going to introduce right now my compatriot, Nick LaFerriere, who is our cloud architect at TAMR, Nick and Nick. So to avoid confusion within TAMR, I'm known as Danger, and Nick is known as Fluffy. If you call us by those names, we will actually respond. So today I'm going to talk a little bit about who is TAMR. I'm going to talk about Dataproc at TAMR. How do we use Dataproc? How does it fit into our architecture? And then the focus of what I'm going to talk about is scaling data development with flows at TAMR and kind of the impact that has on our use of Dataproc, which runs us into a little bit of a bind between user experience and efficiency and kind of ease of technical deployment. And then we have this question of, hey, Dataproc, big cluster, things will run fast versus ephemeral clusters. Is there a way that we can get the benefits of a static cluster at the cost of an ephemeral cluster? The answer is yes, but now we're going to go on a journey. How do we get there? So first things first, who is TAMR? TAMR was founded about 10 years ago when Mike Stonebreaker and his lab at MIT were looking at, hey, big data, you've got these 3 Vs, you've got volume and velocity and variety. And there are great technical solutions for data volume, things like this Dremel paper and BigQuery and other such things. There are great solutions for data velocity. I've got Kafka and I've got Dataflow, but there's no technical help for dealing with data variety. If I have 10,000 databases that are purportedly storing information about patients, how do I get them all together? The schemas are slightly different. How can the machine help me do that? So I kicked off a project at MIT looking at, hey, can the machine actually help with data variety? The answer is yes. And TAMR was founded to take that technology, take that finding, kind of bundle it up, commercialize it, and package it in a way that customers could deploy in production on their own infrastructure. So TAMR, in taming data variety, takes on this really difficult challenge of how do organizations take this wide variety of data that they have and turn it into clean, accurate, mastered data products that their organizations can benefit from internally. And managing data as a product means that data is fresh, it's up to date, it's managed as an asset, but it's also managed as a product, which means there are versions, there are change requests. I can submit a bug against that thing and someone will actually fix that bug. And what TAMR is doing right now, especially with our TAMR Cloud, is we're providing data product templates and a managed service for our customers to go and deploy data products in their organization so that they can bring all their data together, get it cleaned in a managed service that they don't have to go and deploy and manage on their own infrastructure, using their own data engineers, using their own IT, and get nice clean data out the back end so they can get those business outcomes without the infrastructure and the operational investment that they would otherwise have to make. At the core of all of that is machine learning. This is one of the key findings coming out of Mike Stonebreaker's research at MIT, that machine learning in close collaboration with subject matter experts is the thing that can actually get you to that point where you can have nice, clean master data, bring all that data variety together, tame that data variety. TAMR, we're taming data variety. You tame that data variety, bring it all into one place, and you can get the desired business outcomes. So that machine learning is kind of the core, that's the central nugget. What we've been doing over the past 10 years is expanding the footprint of the capabilities that we bring to bear to actually clean up that data to help our customers deliver good data products into their organization. So let's talk about Dataproc at TAMR. This is a reference architecture diagram about how TAMR Cloud integrates with our customers' data infrastructure. So on the left-hand side, you've got our customer data systems, applications, databases, files, APIs, all that data variety that makes the data really hard to use. Customer ETL brings that data into a staging zone where TAMR Cloud can then pick it up. We run it through this flow. That flow, you see the little boxes in the middle, are all the things that I've been talking about. We're cleaning and standardizing that data. We're aligning it with the target schema. We're doing enrichment. We're doing that record mastering, consolidating the records so that if I have, for example, my customers, I can see who are these people really. Bring all that data together so I get that 360 view of who those people are. And then we deliver that out to a published zone. Customer infrastructure picks that back up and deploys it to their BI tools, ML models, what have you. On top here, we've got a couple of applications. We've got Studio, which allows our customers to go in and see their data, which is a really critical capability. You can't trust data if you can't see it. And then a complementary capability, Curator, which is data's not perfect, machine learning's not perfect, and in order for that data to be trusted and actually used as a data product, people need to take action on that data to make corrections to that data, and that's what Curator is all about. I'm going to focus on flow execution. This is where Dataproc really comes to play in the TAMR architecture. So I'm going to turn that architecture a little bit on its side. This is our internal architecture, and how is that TAMR Cloud platform built, and where does Dataproc fit into that TAMR Cloud architecture? So on top, we've got the UI and applications. That's the Studio and Curator that I was talking about. That's our control plane. The data plane, everything else on the slide is the data plane. We've got this flow execution thing. I'm going to spend a bunch of time talking about flow execution, but flow execution is I've got data that's in that landing zone, that staging zone. I need to do all these things to it, and then send that back out to customer infrastructure so they can get the benefits of it. TAMR Cloud is delivered on top of GCP. GCP has all kinds of great services that we bring together in order to deploy and deliver TAMR Cloud. It's a fantastic platform where we're using a lot of different services, Dataproc, but also Bigtable and BigQuery and Cloud SQL and a bunch of other stuff in terms of managing security and et cetera. So I want to talk about flow execution and how Cloud Dataproc fits into flow execution. I mentioned earlier that machine learning is one of the central findings that TAMR really started with. Machine learning really helps this taming data variety problem. So let's say that we have a goal of cluster together records that represent the same real-world entity. How do I do that? I take each record, I compare it to each other record. Do these represent the same person? Well, that's an n-squared problem. I'm comparing everything to everything. It's going to take a really long time if my data is big. And if my target is billions of records, I don't have the lifetime of the universe to spend going and doing this. So I can be smart about the problem. There's a bunch of standard techniques out there, some of which we've pioneered, about how do you chop this problem up into small pieces and how do you identify a whole bunch of the work that you don't need to do. But you're still n-squared complexity even after you've pruned this problem down. And one of the things that we've done is figured out how to chop that problem up into little pieces that can be run on distributed compute infrastructure. That's Spark, that's Dataproc. It works really well. We spent 10 years fine-tuning this. How well does TAMR do? Let's say you want to deduplicate all the people in the United States of America. I've got 300 some odd million people in the country. We'll throw a bunch of extra in there as duplicates, so I've got 500 million, half a billion records. I want to deduplicate those. Well, we can do that. It's going to take a little under 4 hours, and your Dataproc cluster is going to cost you a little under $300. That's a pretty fantastic result. But that's if you're starting from scratch and you know nothing. If you come back a month later and 10% of that data has changed, and now I want to rerun, we're not starting from scratch, we're starting from a pre-deduplicated result. I got that 10% change. Well, we can run that in under 2 hours, and it's going to cost you under $100. That's fantastic. Now I can go and actually work with significant populations of data, tackling this n-squared problem in reasonable time at reasonable cost, which is great, but I don't want to do that just once. I want to do that multiple times. And I don't want to do it myself. I want my customers to be able to do it, which means I need security. I need tenant data isolation in my cloud platform. I need availability. My customers need to know this is going to run predictably. They're going to get results when they need them. I need infrastructure efficiency. I can't just burn thousands of dollars a month to stand a cluster up that might be sitting idle. I need ops efficiency. I don't want hundreds of people kind of doing the care and feeding of this whole thing, et cetera, et cetera. I need to do this in production with reasonable cost, reasonable efficiency. Well, that's Dataproc. Dataproc is fantastic, really fits the bill for all of these things, and it helps us deploy our machine learning into production for our customers for their benefits so they can deliver their data products to their organization. But we're not just doing people. We're doing people, we're doing companies, we're doing sites, we're doing oil wells. If you go to the tamr.com website, you see a bunch of use cases in there. We run our data cleaning on a wide variety of different types of data. So we have our internal teams that are developing these data product templates that are the jumpstart, the bootstrap that we give to our customers so that they can deliver their data products. They don't have to build the whole thing from scratch. We've got a template that says, hey, if you're deduplicating people, here's how you do it. If you're deduplicating oil wells, here's how you do that. That means we have development teams that need to edit, test, and deploy the different pieces of that template. They need to build that in dev, test it, deploy that to stage, promote that to production. We've got multiple teams that are working together. They need to coordinate. They need to upgrade their flows. We have infrastructure upgrades. New Spark version is released. How do we handle that? Basically, we need software development for data pipelines. We talk about data ops. And within TAMR, we've developed a technology, a layer for our data plane that encapsulates a bunch of the principles for running data ops and embodied that into Flex. So I want to talk about Flex. And Flex is one of the key technologies that we've developed that helps us scale our data development organization with flows. So Flex is flow execution. It translates DevOps principles for data ops. I want lots of teams working relatively independently with clear interfaces that can deploy pieces of these templates, pieces of these flows with good independence, with good testing, and deploy those things out into production. So this is data infrastructure as code. You can think about this as Ansible for data pipelines. So Flex, just as an example, here's a flow that is going to go and deduplicate. I think this is companies, organizations. The flow is the end-to-end process. I want to deduplicate all the people in the United States of America. That's a flow. That flow has 11 steps in it. Each of those steps does one thing, like I'm going to apply a clustering model. That step is kind of a mini pipeline. So that apply clustering model, there are actually 8 different stages that we do internal to that apply clustering model. There's a team that manages that. They're working on that data pipeline. They're upgrading it. They're adding new capabilities to that. But they're doing that independently of another team that is, for example, doing third-party data enrichment. data enrichment is a really crucial piece of being able to clean data and deliver it as a product. So we have a team, for example, that does address enrichment, manages third-party address enrichment. That team is currently upgrading our address enrichment capability to use Google Maps to do address enrichment. We use lots of Google services. We're a Google Cloud platform. But that team can now do that upgrade and change which service we're using for address enrichment without disrupting the rest of that data flow, the rest of that template. So the folks working on clustering don't need to worry about what service we're using for address enrichment. So Flex and this kind of declarative way of describing an end-to-end flow allows different teams to work on different pieces, and that's great. It allows us to scale our development, allows those different teams to upgrade their pieces and do development on their pieces. It all fits together and runs, but there's a downside. So as a little aside, a reminder to about half of you about running a Spark application, and maybe new for the other half of you. When you run a Spark application, I've got a client, so Flex has the client here. Flex is going to go and run a Spark application on Dataproc. It's got that Dataproc client library for going and talking to the cluster. Out on the cluster, there's a driver that is actually going to do the work. That driver has application jar files in it. Those jar files need to get out to the executors. So for the deduplicate all the people in the United States example, we had 30 executors. Those jar files need to get copied out to 30 different executors. That takes time. The TAMR application jar, we've actually done a huge amount of development over the past 10 years of all the different capabilities that you might want to deploy in this kind of distributed compute infrastructure to do data cleaning and data standardization. We've got a DSL for that. That thing has a lot of capabilities. It brings in a lot of third-party jars. That thing totals about 2.5 gigabytes. So now I've got to get 2.5 gigabytes out to each of 30 executors, and unfortunately it takes time. Here's the time. This is a bummer. I've got 11 steps in my flow. Deploying those jars takes about a minute each, which means I've got 11 minutes of overhead running a job, as for each step I'm deploying that Spark application, running it, and then grabbing that data, deploying the next application, running it. So on a 2-hour job, that's like a 10% overhead. It's not that big a deal. We end up with a lot of relatively small jobs. Our users are developing data products, and they want to do development and testing of their data product on small data. So they run small jobs. And if I have a 10-minute job with 11 minutes of overhead, that's kind of a bummer. I've got a 21-minute job that should be just a 10-minute job. So we tried various things. Hey, let's throw an autoscaler at this thing so we can scale the cluster up when it's running something, scale the cluster down so we're not paying for idle time. But the autoscaler is too slow. It just doesn't respond quickly enough. By the time that 10-minute job actually comes up and runs, that finishes, the autoscaler starts scaling the cluster down. Now that user is looking, oh, I need to make a tweak to my data flow for my data product. I'm going to run that thing again. It's still scaling the cluster down when they want to run the next job. Now that they've got to wait for it to scale down, then back up. And so they end up with this really bad user experience where it's unpredictable. They don't know how long the job is going to take. Maybe it's going to take 11 minutes. Maybe it's going to take a half hour. So then we have ephemeral clusters. We love ephemeral clusters because we don't have to pay idle time. We have just the compute that we're actually going to use. But that increases our overhead from 1 minute to 3 minutes. You might hear 90 seconds in here. It's more like 3 minutes, 2 to 3 minutes that we see actually deploying an ephemeral cluster and having it ready to use. We're still paying for that overhead, and it's a bad user experience because now it's 3 minutes per step instead of 1 minute per step. So we kind of want our cake to have our cake and eat it too. Can we get the benefits of ephemeral clusters and the benefits of static clusters at the same time? There are other benefits we would like to get from ephemeral clusters in terms of tenant isolation. We can spin up a separate cluster in an account dedicated to that tenant. That gives us strong isolation of tenant data. It gives us billing transparency. We can stick that cluster into a separate billing account and we know exactly how much compute is coming from each tenant. We can have fit-to-purpose cluster composition for those Dataproc clusters, et cetera. Lots of different benefits from ephemeral clusters. We love ephemeral clusters, but the startup time is killing us. So how can we get rid of that startup time? I told you at the beginning that yes, we can get the benefits of ephemeral clusters and the benefits of static clusters at the same time. This is how we do it. We have an internal tool called Spark. So Spark manages Spark. You talk to Spark with Spark. And because we love naming and we love cute names, Spark manages MindMeld. I know there's another MindMeld out there in the Spark community that manages AI stuff. This is a different MindMeld. But the key idea behind MindMeld and Spark is MindMeld takes that driver. We have that one driver that implements the TAMR DSL that can do all kinds of different things, and it's going to turn that driver into a reusable driver. So we can use that to run multiple applications, not just one. And then Spark, on top of that, gives us reusable ephemeral clusters. So what does that mean? Spark, on the left-hand side, it's a service that offers a uniform interface to various types of Spark clusters. So in particular, Dataproc ephemeral clusters, I don't need to worry about how to spin up a Dataproc ephemeral cluster. That's baked into Spark for me. What I do is use this simple API to submit my application description along with the cluster definition, and then Spark goes and figures out, oh, I need a cluster for that application. Do I have one available? I'm going to create a cluster. If I don't have it, I'll deploy that application, and now I can just run that application through Spark, and I don't need to worry about how did that get deployed, where did that get deployed, and then I've got simple APIs for querying status and making sure I can get results. MindMeld is managed by Spark. So MindMeld is a driver that takes an existing user Spark driver, wraps it up into a service, a long-lived service that you can talk to and submit multiple applications. And if you look at the simple API for MindMeld, it looks very similar to the simple API for Spark, minus the cluster specification. So just looking at that Spark lifecycle, what I'm going to do is submit a job with that cluster config. Spark says, hey, I've got this new job that wants this kind of cluster. Do I have one available? If not, I'm going to spin up a new cluster, an ephemeral Dataproc cluster, and then I'm going to take the driver for that application. I'm going to wrap it up in the MindMeld driver. It takes care of that for me automatically. I, as an engineer, don't need to worry about how to go and create a long-lived driver. Spark does that for me, deploys that out onto my ephemeral Dataproc cluster, and now I have something sitting out there waiting for a job submission. I submit that job, run the application, get the results back, I'm happy, and now Spark sits there and it monitors that cluster, and it's waiting for another job. If no job comes in within the timeout period, something like 10 minutes, it tears down that cluster and throws it away. So next time a job comes in, you're going to pay the overhead for the cluster again, but if a job comes in before that 10 minutes, it's going to reuse that cluster. So that's how we get the benefits of an ephemeral cluster and the benefits of a static cluster at the same time. So just going back through, what does this look like on the inside? When I'm running a Spark application with Spark, I've got my client, that's Flex again, and then instead of a Dataproc client, I've got a Spark client, and Spark is actually a long-lived service. So I'm going to talk to this service that's in the middle to go and run my driver out of my Dataproc cluster. That Spark service there's that application that is talking to the outside world, that is exposing that simple API, and then I've got a lifecycle controller. That lifecycle controller implements that flowchart we're just looking at about, do I have a cluster, is it available, do I need to create one, as well as keeping track of application state. Is an application running, is it done, what's the current state of the application. It also takes care of wrapping up the driver, so you can see on the other side there, the user driver that's wrapped up with that MindMeld driver and that lifecycle agent that monitors applications deployed on the executors out in Spark land. So now we're deploying that application jar once. We're able to reuse that for all 11 steps of that flow, and then that cluster sits there waiting to see, is there another flow that wants to run? If not, it gets torn down so we don't pay idle costs. If yes, then I don't need to pay startup costs anymore. That application jar, that driver is still sitting out there on the cluster ready to use. So this has great results. If you run one flow with Spark, now I've reduced my overhead from 11 minutes to send those application jars for each step down to just the 3 minutes to spin up the cluster that first time and deploy the application jar. That's 70% less overhead, and on that 10-minute job, I've taken my end-to-end time from 21 minutes down to a much more manageable 13 minutes. This gets even better if I'm running multiple flows. So this is a user interaction that we see as our users are developing their data products, and they want to make sure that data is good and fit for purpose. They're running some subset of their data, relatively quick job, make a change, and then run a very similar job shortly thereafter. Now they have zero overhead. The application is already deployed, the cluster is already running, it just runs, as though it were a static cluster with all of these things pre-deployed. So now we're down to 0 minutes overhead, and my 10-minute job actually takes 10 minutes, which was the goal. So that's how we get our cake and eat it too. We can have long-lived ephemeral clusters, we can have long-lived drivers, and we get all of these great benefits of Dataproc in terms of the management, the security, the billing, and everything else. This is a great state for us to be in, but that's not the end. There's more that we can do. Serverless has even shorter startup time. Can we actually take care of serverless? We haven't really looked into that yet. We would love to bring that initial cluster creation time down even further. Can we run multiple applications per cluster? We should be able to. Spark is pretty simple at this point. It's not very clever about deploying multiple applications, over-provisioning clusters, or anything like that. So there's more that we could do there. We could play with Dataproc instance types. We would love to look at ARM instance types. It looks like we can get similar performance at significant cost savings. And we would love Dataproc version heterogeneity. So there's an 11-step flow that runs. That flow all needs to use the same version of Spark. It's all 3.2. 3.3 is coming out. Not being able to use 3.3 until that entire flow has been upgraded to run on 3.3 is kind of a bummer, and we would love to be able to upgrade individual steps of our flow so we can have this heterogeneity of some steps run in 3.2, some in 3.3, and the developers never need to know. We just upgrade as we can. And then, I don't see Chris, if there are BigQuery folks in the audience, there's this communication between Dataproc and BigQuery that we would love to facilitate, where to support our users and debuggability, we take the output of each of those steps in the flow and dump it into BigQuery, and then we have this great user experience where our users can go in and look at the output of each step to understand what's going on with their data. It's a fantastic user experience. And then Dataproc picks it up from BigQuery, but it doesn't need all of the data on all of the nodes. And we would love if we had predicate pushdown into BigQuery. So that's my pitch for predicate pushdown into BigQuery from Dataproc. So overall, this is just kind of a quick overview of how TAMR is deploying Dataproc in production for our TAMR Cloud service, helping our customers build data products for their internal use, giving clean, mastered, curated data fit for purpose to achieve their business goals, and Dataproc is kind of at the center of that whole thing. Thank you.
Awesome. I think next up on the agenda is fireside chats, but before we do that, we're actually going to go on a quick break for 10 to 15 minutes. So if everybody could come back here by, let's do 6:45. That'd be awesome. Thank you. Welcome back in, everybody. I think we'll give it maybe another minute. Thank you for still sticking around.
We had a lot of great questions during the break. I've been encouraging people to repeat their questions so that other folks can hear them.
Didn't they lose 10-9, I think? Yeah.
Ooh, that's a close one. All right, let's get started. So let's do a quick round of introduction in case we got some new faces that triggered in. Jay, you want to start from that side, and then I'll round us out at the end?
Hi, everyone. My name is Jay O'Leary. I'm a customer engineer in data and analytics. Been at Google about 3 years.
Nick Bateshouse, also known as Danger, and I'm chief architect at TAMR. I've been at TAMR for about 10 years now.
I'm Nick LaFerre, aka Fluffy. I've been at TAMR for about 8 years, and I'm our lead cloud architect.
And I'm San Tongprasert. I run the customer engineering team at SADA for our New England and New York region. So really this session is intended to be a little more informal, I would say. And it's intended to be just having a bunch of, you're all just going up to the microphone, lined up, ask a bunch of questions to really any one of us here. So please don't be shy. Make it a little engaging. I guess anybody has any questions so far, or any questions that I know Danger said there were some great questions during the break. We do want to hear them. If you have questions, there are 2 microphones on either side. Yes, please. Yeah. And I guess while you're making your way up, I can start us off too, just for one of the 2 Nicks. So kind of curious, when did you start evaluating Dataproc, and then like why did you pick Dataproc?
I think, well, the journey I think starts way before then. So we've been Spark users for I think around 7 years or so. I think it was when 2.6 came out. So we were, at the time, we were still selling packaged software that had to work both on-prem and in the cloud. So we were actually building against cloud error. And then as we were both growing in the cloud for testing our own code, and our customers were growing in the cloud, we really started looking into the cloud-managed Spark and Hadoop environments. And for us being a GCP shop, the first one we built on top of was Dataproc. And it was very clear, obvious on that I come from a DevOps background. I get hours in my week back not having to troubleshoot HDFS and cloud error issues and trying to automate spinning up clusters on the fly. That Dataproc was actually, I think I literally saved probably 8 hours a week out of my job not dealing with cloud error in place for Dataproc, and we've never looked back since then.
Nice. I mean, that's 8 hours of extra productivity, right? To drive additional things. So I guess the follow-up question to that would be like, with the way that Dataproc is structured today, it takes load time no matter how you go about it in a way. Why don't you just keep a bunch of like ephemeral nodes up and running? Because those could be reclaimed at any given time. So in essence, like you could spin up a few, let them sit idle for a few minutes too, right?
I mean, that's kind of what we do. I mean, we keep the clusters around for about, with the MindMeld driver, keeps it around. I think right now we set it for 10 minutes, that if it hasn't gone a new job in 10 minutes, it then tears down the cluster. So we effectively do that already. When you start talking about the spot instances in terms of the ephemeral nodes, there's a lot of things that end up happening at that time. Of you can have your Spark tasks then crash and you have to recompute it. And sometimes if you have too many ephemeral nodes in your cluster and they're cycling at too high of a rate, your job may never finish, which isn't the funnest thing in the world to debug.
True fact.
So we've actually, for the most part, stayed away from spot instances just because of that fact. Because we've been burned a few times by it, and just investing in shutting the clusters down and ephemeral clusters as a whole. So the spot instances have been a good balance for us.
Awesome, thank you. Dave, or questions? Yeah, please.
Hi. Yeah, so thank you for the amazing presentations. It was very insightful. So I had a question about Spark, and I spoke to Nick about this earlier, and I was asked to repeat the question. So it goes. So basically, I understood Spark as kind of like managing sort of compute power per driver and sort of assigning it to different jobs that come in. So my question was, does it then rely upon continually feeding jobs instead of just, let's say, one job to be time effective and cost effective?
Yeah, so there are a couple pieces to that. One is Spark is relatively naive. It's a relatively simple thing. And it will just run whatever application, whatever job is handed to it. And it's not particularly clever around how it allocates those to different clusters. And then the other piece is the compute that we're running is really our customers' compute. So if we could manage the workload, we could probably level things out and distribute our compute over time so that something like a static cluster would be more effective. But we are selling mastering as a service to our customers, and they want to run their jobs on their schedule so that the data is ready for them when they want it, which means that our compute is unpredictable to us. And that's where Spark comes in terms of managing these bursty workloads.
Thank you so much.
Can you talk a little bit, and you guys are laughing that I'm asking a question, about why TAMR chose to build your solution in Google Cloud over other cloud providers?
There's a lot of reasons. I think we actually started the company on AWS and then eventually switched over to GCP in large part just due to the fact that, as Jay was talking about earlier, big data is in Google's DNA, where it's using Bigtable, BigQuery, and GCS we thought were far better services for our workloads than anything AWS had, and it was far more cost effective for us to run on top of GCP, at least for our workloads dealing with big data.
I'll throw the ops aspect of that in as well, which is managing the same services on AWS or other cloud platforms still requires a lot of ops knowledge, whereas something like Dataproc is actually the ops element of that, or the ops aspect of that, is much less. We can just deploy it, it runs, we tear it down, we're done. And it's kind of pre-configured. I spend a lot of time on security. I think a lot about security. And getting the security right on Dataproc is kind of the default. It kind of pushes you in that direction, whereas on something like EMR, you really have to think about it. You have to design it very carefully.
See, there's another question.
This is a more open-ended question, but how do you see the data products landscape changing with the advancements in generative AI and large language models?
Does anybody have a timer? How long did it take for the generative AI to come up? I think it does stand to make a significant impact in data cleaning and data products. We've absolutely been working with generative AI and looking at what can generative AI do. And we've been looking at it from the perspective of one of the things that we get often is the TAMR data platform has done something with the data and produced a result. Why? What's the explanation for why you have this result? And generative AI is actually, if we can give it the right data, the right context, it's really good at generating a narrative around that our business users can understand. So that's one thing that's kind of really neat from a generative AI perspective. The other thing that we've been looking at is the embeddings that are used for things like ChatGPT or Bard. Those embeddings can actually be really useful in providing a semantic understanding of the data that then can help our deduplication process. And so we've been looking at how can we maybe get some of those generative models into our flows to help with the deduplication process. That is another one of those things that if I, as, I don't know, a healthcare provider, want great data on my patients, I don't want my engineers spending time thinking about how do I get generative AI into my pipeline so that I can get better deduplicated patients. Whereas TAMR, as a provider for this kind of managed service for mastering, we can start incorporating that into our templates for folks. Great question. We knew it was going to come up.
Curious to see how, how all these companies like Google deal with the compute needs for generative AI. We have it internally in workspace documents, so you can basically deliver a prompt, say, give me a summary of the meeting I just had based on my meeting notes. And there's, I don't know, maybe a 30-second or so lag. So maybe they can use Flex and Spark to optimize that. But it'd be really interesting to see how companies deal with the compute needs for generative AI.
Hello, this is a follow-up on the security question.
Coming from General Dynamics OTS, how do you treat customers with mill-grade requirements and air gapping, bare metal? What do you do with military grade?
It's a journey.
It's a big journey.
So kind of two different pieces to that story. One is we do still have an on-prem platform that can be deployed in an air-gapped environment, and we do that. We have customers running it air-gapped. And that is, it's TAMR core. That core is the same core that runs in cloud, so you're getting the same technology in both cases. For TAMR core, for that on-prem, we don't have as much facilitation in terms of templates and flows and external enrichment and all that kind of stuff, but you do still get that same core of technology. And then in terms of a cloud journey, one of the reasons we like GCP as a platform is it helps us chart that course for how do we get to FedRAMP or other qualification that is going to let us serve those organizations.
For the cynics, the question. So now that we're just talking about generative AI, I'm wondering what's the cybersecurity take on TAMR? Like, how do you guys manage privacy and cybersecurity within your clients, and what's your thoughts on that?
I'll pitch a little bit of GCP. So one of the things that we love about GCP is how much security is baked into the platform. For example, things like everything's encrypted by default, so it's kind of hard to mess that one up because you can't. Versus it is in some of the other clouds, it's very tricky to kind of even get that working sometimes. But the other one of the core things we've built into our architecture for our cloud offering is dedicated resources for our customers, where we can very easily spin up a Google project for our customers and then put BigQuery data sets unique to them, GCS buckets unique for them, use their own secret manager instance inside that project, and issue KMS keys for them. And then if they ever have to offboard for things like GDPR, we can just delete the keys and the data is immediately inaccessible. And being able to, especially when you then start getting into the details of some of the things like running Dataproc clusters with shared VPC networking, is a lot easier to do on Google than trying to do something similar in AWS. You'd have to spin up a lot more resources, a lot more things to manage, a lot more things to go wrong. That it's been very easy to kind of do this kind of modern, having dedicated resources and assets for customers top of GCP compared to some other cloud providers.
So another question for Fluffy and Danger. You touched, I think, a little bit, Nick, in your talk about trying to use serverless technologies as well to do this sort of computation. Given now, especially in the last year or so, that you can call out to functions from, say, BigQuery, that you can compile down and run custom UDFs with like Python or JavaScript, have you guys considered any way of like running similar workloads kind of in a fully managed environment, like BigQuery, or is that just not a good fit for your workload?
Actually, yes. That's kind of the next steps on our thing that we'd called out. For us, having this, we've been a company for a while, going through the Spark journey for several years, that things like the serverless Spark, you have to be on the newest version of Spark to use it. So getting there so we can even then experiment to it is kind of, we're just now getting there now to experiment with it, and something that we do want to invest some time in going forward.
One of the so having been at TAMR from the very beginning, I know where the skeletons are. One of those skeletons is the very earliest version of the system was written in SQL, and it ran on Postgres. And people might be making the connection between Mike Stonebreaker and the early technology being developed in his lab and Postgres, which is a correct connection. So the very early versions were implemented in SQL. There were a lot of challenges. One of those challenges comes from, just like our workload is determined by our customers, our schema is determined by our customers. So we don't know what data we're going to process. And in a structured SQL environment, that becomes a big challenge. In a context like Spark, we can go and create schemas on the fly, and it's not that big a deal. And those schemas can kind of propagate through the data process relatively easily. BigQuery in particular has enough schema flexibility. We might be able to offload some of our workload into something like BigQuery, but the schema versus flexible schema ends up being a significant challenge there.
Thanks.
So just a follow-up question on that. So how easy it's for developer or an architect to integrate the pub sub with this and like effectively run it on top of BigQuery? Yeah, so
Yeah, so being Spark from a long time ago, we're still primarily batch, and our goal has been kind of constantly trying to get more towards micro batches. But for us, for that specific question, it would be you'd stream pub sub topics into a BigQuery instance using the pub sub to BigQuery streaming kind of interface, and then we would just load it at the start time of the job from BigQuery as a bulk job.
We have a lot of customer interest in streaming workloads, and we've developed kind of packagings of our technology that really support streaming. We haven't deployed those into the cloud platform yet. There's a cost effectiveness kind of question there. How do we get the cost for deploying those streaming workloads down enough that we can give them to our customers at a good price point?
and just one more question. Also, could you highlight like where in the stages, if any customer or maybe like you as architects want to heavily rely on any bad job or any kind of scheduling any specific jobs, if it could be on top of preemption or priority. So is there any scheduling mechanism to run those workloads, or how do you like try to work on that?
So as I think I mentioned before, it's the spot instances, we've had kind of a checkered past with them in terms of Spark and some of the like it causing jobs to never finish. So we tend to avoid that specifically for our workloads just because we know it doesn't work very well with a lot of our Spark code and how we like our chunks of task and retrying them. But then in terms of the kind of larger things and priority of kind of clusters and jobs, well, GCP has a lot of infrastructure. It's hard to run out of resources on the cloud. I think we've tried a few times and may have come close to it and got told wait 15 or 30 minutes and then run your job. But generally speaking, like that's one of the benefits of being on the cloud is that you can scale that dynamically when you need to.
Sure. Thank you so much.
Thank you very much for your talk and for all of the information you provided about the data. But when you were giving your talk, Mr. Nick, you were mentioned that everything that you are doing is based on ML. At the same time, you have all of these different customer source of data. So it's really interesting to me as an ML scientist to know how you handle the ML, especially that your data is not killing when you are getting it. And the follow-up question, you have these curators. I was interested to know whether these are like people on your company or you are sending the data, receiving the feedback, and it's a feedback loop with your customer. I would appreciate it. Thank you.
So the first question I think I've got, which is ML is kind of at the core of TAMR. It's been at the core of our journey. How are we managing that? The second question, maybe I'll have you repeat it after we go through the first one. So the first question, how are we managing that ML? One, very carefully. We have teams that are working on that ML, making sure that the models are developing correct results. And it's a real challenge. Again, we develop the models on our data, and then we deploy them, and our customers use it on their own data. And it's one of the reasons that Studio and Curator and integrating BigQuery into our environment so they can look at those results very quickly is so important to build trust, so that our customers can see what the platform is doing with their data and understand it and trust that what the platform is doing is correct. Exactly how we implement that ML is kind of an open secret. We have, I think, 16 patents out there that actually cover a lot of the different aspects of what we're doing in various pieces of machine learning and how that learning is gleaned from subject matter input, subject matter expert input. And going back to the origins of the company, that key observation that Mike Strombrecher made in his lab and his early research is that getting the machine learning to do the right thing without going off the rails requires this really close collaboration between subject matter experts and the machine learning so that the machine can learn directly from the experts without some kind of intermediary and without a larger feedback loop. And so a lot of what we've looked at over the past 10 years is how do we get an interface that subject matter experts can understand that will also provide the insights, the data, the really training points that the machine learning needs in order to get traction and go and do something that gives good, high-quality data results. And when I talk about the distributed engineering team that's working on our data product templates now, one of the key pieces of that is we have data scientists, people who really understand data and are kind of instant experts in the various domains where we're building these templates, and are able to kind of assess quality of results that are going and training these models now that we can package up, put into these templates and deploy for our customers, so that the customers don't have to get into that whole training workflow. They have a pre-built model that they can just run and get the high quality results. And having this kind of distributed development team for the data pipelines, where we have different kinds of expertise working on different pieces, is one of the things that really helps us focus in on, yes, we have a team of experts working just on those models, just on that training, making sure they're as high quality as possible. What was your second question again?
You already answered it throughout the first question, so I was interested to know how you are confirming that this data is clean. Obviously, you need a human feedback. I was interested to know whether these are in-house people who are helping you, or you are sending it back to your customer. Obviously, through the studio, you are building this basically interaction with your user to know whether this product is what they are expecting. So it's really genius.
Yeah.
Thank you.
Yeah, so the answer is really both. We have an in-house team that is training the models, testing those models on our internal data, validating that those models are producing high-quality results. Then we deploy those into our templates, our customers can use them, and then we're giving them Studio, where they can see the results and assess for themselves whether the model is doing the right thing. And they also have Curator available there to make any tweaks that are necessary.
If I can ask another question. I'm sorry. It's an ML thing. So, as I guess you know a lot about ML. So here's my question. When the problem comes to you, are you going for an off-the-shelf architecture and you are just choosing the right data to make sure that the product is what you want? Or you are tweaking the architecture to the point you want? Or you think that something else like a loss function is what exactly makes it build what you want it to build?
It's always a conversation. There's always a conversation between the modeling and the data. And I'm not a machine learning expert. I've worked alongside a lot of machine learning experts, but I myself am not a machine learning expert. But we're constantly figuring out how to improve that source data in meaningful ways so that the machine learning can get better traction, and what are the what are the features that we need to use, what is the structure of the model that we need to use. The model right now is actually really complicated. When I talk about clustering as an 8-stage pipeline, we're doing a bunch of different things in there, each of which independently might be considered its own machine learning model. But then one of the things that we found, our CEO, Andy Palmer, is really fond of saying, if your data is not good enough, what you need is more data. And we find that third-party enrichment is extremely powerful, both from a data cleaning perspective. We bring in this third-party data that has standardized addresses and names and what have you. But then it also gives us additional information. It can fill in missing values. It can fix erroneous values. And all of that gives the machine learning even better traction for what it's trying to do. Right? The third-party enrichment and standardization, it's not a panacea, but it really helps the machine learning. And so there's this constant conversation between what can we do to the data, what can we do to the machine learning. There's an advance. Now, what can we do to the data? What do we do to the machine learning?
Thank you very much. I appreciate it.
Like another questioner you asked that I asked the question. I was very curious when you said predicate push down, please. I assumed that was some kind of view thing, right? And I asked you between Dataproc and BigQuery what's going on, and we got to the point that Dataproc and you're not even actually using the SQL engine. You're talking directly to Colossus, basically. So if you could expound on that, that'd be cool.
So over the last couple of years, Google's been really good about, as it's growing BigQuery and growing its data products, data engines, I guess. I don't know what to call it. But one of the things they introduced semi-recently was the offline storage access for BigQuery, which that is then packaged up in their Spark driver, which allows you, it basically bypasses the front end of BigQuery and goes to Colossus and then gives you the data back as raw RDDs, so you can go and use it. But you can't push down queries to filter out the data you don't want. So you have to basically suck in almost the entire table. But it is much faster. The throughput is much, I don't know, larger. It's significantly more performant than trying to go through the SQL interface and streaming it out.
Like anything that touches BigQuery, it is stupid fast.
I had a second question, which was, I think the first fellow, is that Jay, the first speaker? Yeah. You said that 90 seconds to spin up and then you pay per second or something like that. Could you explain that phrase?
So 90 seconds was I think Nick
You want to use the mic?
Nick contradicted me a bit, where 90 seconds is probably optimistic, depending on what you're doing, but then you pay per CPU unit after that.
So you're not paying for the 90 seconds.
Oh no, it does include the 90 seconds. So I guess the way I phrased it, I guess, was the issue.
There's probably a lab environment in which we could get 90-second startup time as well. But what we find in practice, it's somewhat variable, anywhere between like a minute and a half, 2 minutes, up to 3 minutes.
And there's a lot you can do in terms of initialization scripts that can,
Initialization script slows it down.
yes, or using an image to, maybe pre-pack your jar files like you were talking about. So there are games you can play, but there's 90 seconds is probably the best you would ever get.
Actually, if I may take Jay's comment as a question, which is, why don't we just prepackage our jar files onto our Dataproc images? And the answer is that, okay, I'll ask it to Fluffy.
I was going to say, as a DevOps person, that means I have to build Dataproc images every 2 weeks for every Spark jar we need, which is time consuming and painful sometimes.
Right, so we've got this distributed development team that is changing, augmenting, and fixing that DSL all the time, and the driver that implements that DSL all the time. So we would have to update our images all the time, and it just becomes extremely costly.
And how does this get updated and rolled out to your customers today?
Well, like any software organization, there's a whole SDLC lifecycle that we document. I think it's 40 or 50 pages now for compliance auditors. But the short answer is package it up. There's a comprehensive testing suite that actually runs a bunch of Dataproc jobs to invoke almost everything in it and almost every scenario we know about. Test all of that, does all the assertions, then it gets deployed to our dev environment where it's then incorporated in our data platform. It runs through all our data platform tests and it makes its way up through into production.
Awesome.
So TAMR has been talking about data ops for a long time, where data ops is you want to operationalize data delivery. And we're trying to live what we talk about in terms of we are running data ops internally as software development, real software development, and then deploy our data product pipeline, data product templates through that dev test prod promotion, just like any other software engineering team would.
All right, thank you for the presentations. Here's a question for Nick. And I have a question for Jay, maybe very quickly. I'm just wondering why, for TAMR, have you considered using a infrastructure that the jobs would be submitted to a single Dataproc cluster, as opposed to creating a cluster for each? Because that sounds like one of the bottlenecks, like 3 minutes or so. You have to wait for the cluster to come up. And yeah.
Yeah, so we've done that before, and the limitation we ran into is actually with the Yarn autoscaler. So Dataproc autoscaling is actually the Yarn from the Hadoop stack autoscaling underneath the hood. That only allows for one autoscaling action at a time. So you can run into scenarios where a job finished, Yarn says there's nothing immediately here, we'll schedule to be scaled down. Now what happens when it's scaling down, it will not evict any nodes that have any running task on it. So what then happens is it will hold that scale down action to that node finishes, and you don't know how long that task is going to take to finish. Then a new job comes in and needs more resources than it's available on the cluster, and it won't start running with the way we have it configured till all the resources are available. So then you end up not being able to start a new job while the cluster is actively trying to scale down and remove resources from you. And that's the scenario where Nick had mentioned in his presentation that just doing a static Dataproc cluster that auto scales can sometimes get you in scenarios where your job never even starts. And leads to very unpredictable kind of times of, hey, user clicks a button, why is it pending on infrastructure for an hour to run? And then it just ends up being a bad user experience.
That makes sense. And if I may ask a quick question from Jay, I'm a big fan of Dataproc myself, but I'm just wondering what's your take on what Databricks claims, which is it's much, much faster than other Spark implementations.
That's a good question. They, under the covers, I'm forgetting now what the engine name is, a Proton or something like that. They have a C++ engine, I guess, that can optimize some of the operations. So I guess some of the operations in Databricks will be a little bit faster, but then you also have some of the limitations of not connecting to the GCP ecosystem. Things that we've added recently to Big Lake, like fine-grained security, where you can use you could use like a policy tag in data catalog to say, give me access, let only certain people access PII as an example. So you wouldn't get some of those features if you used something like a Databricks.
Awesome. I know we're right at time. Any last minute question from anyone? All right. Awesome. Well, thank you everybody for coming out this evening. Supers. Again, thank you for all of our panelists and also presenters as well. And yeah, I hope we have like a few more minutes to at least hang out, chat, and network in the lobby maybe, or like in the waiting area for those that do want to just hang around and chat. I'm sure our panel will be there as well. Thank you.